Good day, Doctor. We are from Group 5, and we will be presenting a colorimetric paper bioassay by Horseradish Peroxidase, detection of Catechol and Resorcinol in aqueous sample. Our group members consist of oxazine, citrulline, subencine, tamlacine, and teiline. What are the issues to be resolved? Ground of problem. Catechol and Resorcinol are toxic and persistent pollutants in aqueous environment and possess serious environmental hazard. Catechol is carcinogenic to humans and toxic to aquatic life. Resorcinol is endocrine disrupting chemical, negatively impacting the bowel life. The conventional method to detect catechol and resorcinol are spectrophotometry and chromatography. The limitations include complicated, time-consuming, and require qualified staff. The available biosensor to detect catechol and resorcinol are optical biosensor using salt jar and primer of lactase, optical biosensor using lactase and chromogen and BTH, and electrochemical biosensor. The limitations include complex construction method, which are like fabrication of electrodes, expensive material use, complex construction method usage of electrodes will increase the cost, and less environmentally friendly. Electrochemical and optical biosensor requires batteries. The real problem intended to be resolved are cost effectiveness. The available biosensors in the market are too expensive. We also want to resolve the complicated construction methods such as integrating photolithography fabrication on electrodes. The problem that we want to resolve is to maintain eco-friendliness. The need to use batteries is less environmentally friendly compared to paper-based biosensor, which is more sustainable. Moving on, let's see what are the significance of using paper-based biosensor on detecting catechol and resorcinol. It is important to resolve the problems mentioned because developing a cost-effective paper-based biosensor can increase the widespread of usage and can expand market size. Simplifying the construction method of biosensor can reduce the overall expenses, reduce the time needed to produce the biosensor, easy scalability, and thus producing an affordable biosensor. Reducing the reliance on batteries can help conserve the mother nature and minimize environmental impact.
What is the application of HRP biosensor? It can be applied in environmental monitoring and wastewater treatment monitoring. In environmental monitoring, contaminants such as trichloroacetic acid, TCA, in water and soil sample can be detected and quantified by HRP biosensor. Why do we need to detect TCA? This is because TCA is carcinogenic and it will cause liver and lung damage, as well as reproductive toxicity. TCA often found in industrial effluent and as a byproduct of disinfection in water treatment processes. By using HRP biosensor, the pollution levels of TCA can be assessed. HRP biosensor can be also used in wastewater treatment monitoring for effluent quality control. The levels of organic pollutants such as catechol and resorcinol can be monitored to assess the performance of the treatment plants. The using of HRP biosensor can ensure the treated water compliance with environmental regulations.
Good day, Doctor. I'm Singh. I will now proceed with the working principle of HRP biosensor. HRP biosensor is a paper-based biosensor which involves the use of workman paper as reaction platform. The workman paper is dipped into the water sample. The water sample will then move along the paper through capillary action. This is achieved by the large pore volume fraction of the paper that supports fast lateral flow. The Horseradish Peroxidase and chromogen 3-methyl-2-benzoyl-dioxylenate hydrazone and BTH is entrapped in ketones cross-linked using gluten aldehyde. The mixture solution contains of 50 microgram per ml HRP and 50 millimolar MBTH entrapped in 0.1% of ketosone using 0.01 gluten aldehyde as cross-linking agent. The mixture was then spotted on the paper and allowed dry. The horseradish peroxidase will convert the benzoyl in water sample into benzoyl semiquinoid. The benzoyl semiquinoid will then interact with MBTH to cause color change based on the concentration of benzoyl that is found in water sample. If there is presence of benzoyl in the water sample, the resorcinol will then change the paper from fade pink to orange with the lowest detection limit of 10 mg per liter, which is equivalent to 0.09 millimolar. In the other hand, catechol will change the color of paper from fade pink to red with the lowest detection limit of 50 mg per liter, which is equivalent to 0.45 millimolar.
Okay, good day to Doctor. My name is Singh. So now I would like to proceed with the method that can be used to improve the performance of the biosensor. So the first method to improve the biosensor performance is the enhancement of immobilization technique. For example, we can use an alternative crosslinker like the ginipin, which is a natural crosslinker, to replace the glutaraldehyde that have been used in the article given. This is because ginipin, it is non-toxic and it exhibits higher thermal and pH stability, which can help to provide a better stability and enhance the enzyme's activity. Okay, beside alternative crosslinker, incorporation of the nanomaterials can also help to improve the performance of a biosensor. For example, we can use the gold nanoparticles or graphene nanoparticles. This is because these materials can provide a high surface area for the enzyme loading, which can help to enhance the electron transfer and also provide more conductive environment for the enzyme activity. Besides, these nanomaterials can also help to increase the bioassay sensitivity and also the detection limits. Next, the method that can be used to improve the performance of a biosensor is through signal amplification by using a secondary enzyme to produce a more intense color change, which can help to amplify the signals. For example, we can using a cascade reaction involving the HRP and also the other secondary enzyme, for example, the soybean peroxidase, which can help to produce a visible precipitate which can amplify the signals. And why soybean peroxidase can be used as a secondary enzyme? Because it is a long-lasting chemiluminescent signals provider, and also it can help to enhance sensitivity and also the stability of a biosensor.
Part 5. The conclusion. The development of a HRP biosensor, a paper-based biosensor for the detection of resorcinol and catechol, offers a promising solution to the challenges posed by conventional techniques. This biosensor is not only cost-effective and environmentally friendly, but also simplifies the detection process, making it more accessible for widespread use. By incorporating advancements such as gene mapping for enzyme immobilization and signal amplification techniques, the biosensor achieves higher sensitivity and stability. The digital image analysis also makes the detection more precise. This invention helps to enhance environmental health and safety by addressing the urgent need for effective, portable, and sustainable monitoring of catechol and resorcinol contaminants in wastewater. In the end, this is our reference. Thank you.